So yeah, so this code is to examine the relationship between CO2 concentration and CO2 uptake. I performed a Pearson correlation test using the following command in R. So the key value is 5.0245, which indicates the test statistics used to assess the significance of the correlation. As for the degrees of freedom are 82, calculated based on the sample size. So this is the p-value. The p-value is extremely small, which is less than the standard significance level of 0.05. This means that the null hypothesis, there's no correlation, can be rejected. In other words, we have strong evidence to conclude there is a significant correlation between CO2 concentration and CO2 uptake. And the confidence interval for the correlation coefficient is this, and this indicates that we are 95% confident the true correlation lies between these two values, further supporting a positive relationship. The sample correlation is 0.482552, which suggests a moderate positive correlation between CO2 concentration and CO2 uptake. And this is my scatter plot. The blue dots represents individual observations in the dataset showing the values of CO2 concentration and uptake. And the red line is the linear regression. The positive slope of the line indicates that as CO2 concentration increases, the uptake rate also increases. The overall pattern in the scatter plot shows a moderate positive correlation between the two variables, as we discussed earlier. And this measures the Pearson correlation coefficient, which is R equals to 0.485 we calculated just now. We suggest a moderate positive linear relationship. From this plot, we can visually confirm the correlation result. There is a clear upward trend in the data supporting the conclusion that higher CO2 concentrations are associated with increased CO2 uptake. And this is my multiple linear regression. The MLR model was performed to examine the relationship between CO2 concentration and predictors, which is uptake, type, treatment. The results show that uptake positively influences CO2 concentration, which is 34.07. The type Mississippi increases concentration by this, and the tube treatment adds on with this number. The model explains 42.7%, and the variance R square is equal to this, and is statistically significant overall with this. The BIF values for uptake is this, and the treatment is this, and the type is this. So in summary, all predictors are significant, and the model provides a solid explanation of the variability in CO2 concentration. As for my Shapiro test, yeah, the Shapiro-Wilk test for residuals was conducted to assess the normality of the residuals from the multiple linear regression model. The test produced a W statistic of 0.9394 and a p-value of 0.000641. Since the p-value is less than 0.05, we rejected the null hypothesis that the residuals are normally distributed. This indicates that the residuals deviate significantly from normality, which may suggest potential issues with the model assumptions. It is important to consider further diagnostics, such as residual plots or transformation, to address this non-normality in the residuals. So that's all for my presentation.